let's get down to the nitty-gritty of the cost of production. Let's imagine our stapling example where we've talked about productivity. Let's say we've turned that into a little business. What are some of the costs that we might incur when we are running our little business? We'll break it down simply into two major areas. There are fixed costs, and these are costs that don't change irrespective of levels of output. And there are variable costs, costs that do vary as output varies. So let's have a quick look at those. So fixed costs, what are we talking about? Things like rent, for example. So let's say we need to rent a room for, say, $100 a week or $100 a month. That's fixed, whether we're working or not. The landlord wants that money. Payments to your, for example, in business, to leasing payments on factors of production such as equipment would fall into this category as well. So some of these costs are fixed. Add them all together, not surprisingly, we'll get total fixed costs, which we'll simply call TFC. Costs of our variable inputs, e.g. wages to labour, will be our major variable costs. Other costs that vary as output varies, maybe use of power, energy, water, supplies, etc. Add them all together, we get total variable costs, and we'll simply call that TVC. TVC. Add them all together, TC. Total cost. Now, we saw when we talked about production and productivity, the usefulness of averaging. So if we do that here, we might take, for example, our total fixed costs and divide it by the quantity of output that we're producing, TP, and in some textbooks this will simply be Q, quantity of output, so that's okay. So TFC divided by our quantity of output, TP, will give us AFC, average fixed cost. Do the same for our total variable costs, TVC, divided by the quantity of output, TP. What will we get? We'll get AVC, average variable costs. Add the two together, what have we got? Not surprisingly, we've got ATC, average total cost. We need one more really, really useful tool for our analysis, and that of course is marginal cost. What's the addition to total cost of producing one more unit of output? So MC, marginal cost, will be equal to the change in TC, so our little delta symbol, change in TC, or as you know, technically TVC as well, the change in TP. In other words, the change in total cost brought about by the change in our quantity of output. Right, I'll take you back to the computer and I'll walk you through this data again. Okay, quick recap. We can see from our screen what we talked about previously, the law of diminishing marginal returns. We can see that when the marginal product of labour is rising, with the addition of the first one or two units of labour, the average product of labour is rising as well, and it gives us a rising total product curve, etc., etc. We saw that when the marginal product of labour was zero, total product maxes out, and we ended up with what we call a hill-shaped average product curve. Remember that there's this key connection between marginal and average value. So as long as the marginal value was greater than the average, then the average was rising. But of course, as soon as the marginal value is less than the average begins to fall. Very important part of our analysis. Let's make the link between productivity and costs. Okay, we've talked about fixed costs. They are by definition fixed irrespective of the level of output. So in particular, we're talking about rent. So for our little example, imagine that we've hired a room and it's costing us $100 a month or $100 a week. And we can see that our average is going to fall quite quickly as output actually increases. So not surprisingly, we'll see that when we come to plot this curve, that it actually falls away almost exponentially towards our x-axis or our horizontal axis where we're plotting quantity of output. Our variable cost, remember we're talking about, we've simplified our variable cost example for our little production process here. We're talking about wages only. So what we're talking about here is paying our students $8 an hour. So clearly one student costs $8, two costs $16, etc., etc. And that will give us our total variable cost because we've simply multiplied our wage rate by the number of units of labour. Now, to get our average variable cost, what do? We simply divide TVC, or our total variable cost, by the quantity of output, or what we're producing in terms of TP. So clearly what we're doing here, we are dividing 8 by 10, and the next one, we're dividing 16 by 25. So what we can see here is that AVC is actually falling. Now, not surprisingly, it's falling, because remember over here, total product or output's actually risen. Remember that second person added more than the first in terms of our marginal product of labour. But you can see here, so you'd expect that when we plotted this curve, that AVC would dip initially, but beyond that point, we'd actually see it begin to rise up. So quite possibly we can expect that what we might call a saucer-shaped or U-shaped curve here. So we'll get to that in a minute. Now, remember our marginal cost is the change in total variable cost associated with the change in quantity of output. So marginal, remember we're talking about extra or additional. What's it costing us here in terms of putting on every other student? Well, we divide here, our starting point will be the same, will give us a value of 0.8. In this particular case, remember that our second student added more than the first. So our change in TVC here, actually our marginal cost has begun to fall. So again, we can actually predict that we're going to see a curve that's going to be falling away and then again begin to rise after some point where, remember, diminishing returns are set in, and we can see that our marginal cost begins to rise as our output expands. Now, here's our key connection, the connection between the marginal product of labour and marginal cost. So again, at the risk of being repetitious, I know you're a bit bored with this, but trust me, this is a really, really, really important part of our analysis, so you've got to bear with me here. Remember that our marginal product was the addition to total product as we added more and more units of labour, and beyond some point, which we identified, it set in after we've added that third person, that returns to labour started to fall. But initially, as we can see, our marginal cost is actually falling. We're getting more and more out of each worker initially, but then when diminishing returns have set in, we see that our marginal costs have begun to rise. So marginal costs are rising as marginal product is falling. Now, when we plot this, we'll be able to see more clearly that these two curves are, if you like, a reflection of each other. So in terms of plotting our data, what do we come up with? As we predicted, an average fixed cost curve. So we started out at a fixed cost here of $100 per unit of output. And then, of course, as we've added, our quantity of output expands. then if you like, the denominator of the fraction gets bigger and bigger, so clearly the outcome is going to get smaller. As we predicted, when we plot our average variable cost curves, what did we say? We said it's going to be falling initially. So remember, this is quantity of output expanding along our horizontal axis, and this is cost in dollars, right? So the actual cost through this range of output, the average variable cost is actually falling, but of course we predicted and we can see that it begins to rise. Add the two together. So this is just a vertical addition of AFC and AVC, and of course these two things added together give us our average total cost curve. And it is, as you can see, it's roughly saucer shaped or U-shaped, a bit like the AVC, but have a look at the distance between the two. The vertical distance between these two curves is getting smaller and smaller and smaller, not surprisingly because AFC is getting smaller as output expands. Our final addition, our little friend, the marginal cost curve. Now, same point of origin as AVC, and very importantly, please note, it must by arithmetic necessity go through the minimum points of AVC and ATC. But in particular, remember that the relationship between our marginal and average values is that as long as the marginal value is less than the average will continue to fall. So even in this little range here where marginal cost is beginning to rise, its value, read off the vertical axis, its value is still less than the average, so the average is falling. So these two curves will intersect at the minimum of AVC. And after that, of course, marginal cost is greater than the average, so the average begins to rise as well. Okay, what do we do now? We need to add to this little profile, this little basic template, this short run average cost curve configuration, we need to add the revenue side of our firms. And we'll do that in our next clip.